Many woodworkers consider veneering to be the most intimidating new skill to learn. But we're going to simplify the process here on Woodcademy as we build this lovely backgammon set. This is a relatively simple project, and there aren't really any unusual hazards that we have to worry about as we have in some other episodes. But as I work with my lathe, I will be wearing a full face shield. I'll be wearing my eye protection under normal circumstances, and of course, I always have my hearing protection in. As always, paying attention in the shop, being aware of what you're doing, not working when you're tired or distracted. These are all common sense items. These are all up here. You are your own best protection in the shop. Backgammon is said to be the oldest of board games, with examples having been found in archaeological digs going back 5,000 years. And if you come from a Navy family like I do, you'll know it as acey-deucey. Rules are a little different, but the board game is the same. Now, to be perfectly honest, I don't even play backgammon yet. But I thought it was much more interesting than making a simple checkerboard for practicing your first veneering skills. And we've done a few things to make this whole process much simpler. I turned the dice cup and the checkers that we use to play the game. But the dice I bought. Now, if you don't have a lathe, no worries, you can buy the dice cup and the checkers and the dice separately and use them on your game board. Or you could simply buy an inexpensive game, throw the board out that comes with it, and make your own. Secondly, I simplified the game board. I designed it so that all of the triangles, the backgrounds, and the two colors for the players are all the same size. So one template allows you to cut all of the veneers you need for the backgammon board itself. This greatly simplifies the process. We're also going to build this set backwards from doing a normal box. Normally we'd build the box and then cut the panels to fit. But it would be very difficult to put all of these pieces together that makes up our game board and fit it perfectly into the opening available. So we're not even going to try. We're going to build the game board first, and then, if necessary, adjust the size of the box to fit. Much simpler to do that way, and you'll get better results. And finally, we're not going to be using hot hide glue to apply our veneers. That's the traditional method, and it works very, very well, but it involves expensive equipment that most of us don't own. And so I'm going to show you a technique using standard yellow glue that allows you to set your parts in place and hold them down instantly without waiting for glue to dry and without needing a vacuum press. So let's get on with the build. Before we get started, let's take a minute and talk about material choices. I made an error here, and I want to make sure you don't do the same. Backgammon, like most board games, uses two different colors of counters to represent the two players. And the tradition is to use a dark colored wood for one player and a light colored wood for the other, and that's exactly what I did. I used walnut for the dark counters, I used maple for the light counters, I had some in the shop, it was suitable for the turnings, and that's what I used. And so those colors directed the veneers I chose for the light and dark triangles that the game board requires. I simply used walnut veneer for the dark triangles I needed and holly veneer for the light triangles. I could have used maple, but holly tends to maintain its bright, clear white color over decades and generations, and maple will tend to darken over time, so I wanted to use the holly for that. The problem comes in with the background material I chose. The part that goes in between the four quadrants that we're going to create and the triangles that go between the two colors. I chose a bird's eye maple. I thought it would have enough contrast and I thought that the bird's eye would give us an interesting look. I was right about the bird's eye, but I was wrong about the contrast. The maple that I got was way too bright and close to the holly. There was almost no way to tell the two apart. So, rather than buying another veneer, I simply applied a little bit of golden oak stain to my bird's eye maple and used that. But in reality, a better choice of background veneer would have been the right thing to do. So consider things like satinwood or pear or steamed European beech, some close-grained, good quality hardwood veneer that will have a natural tan to rose color to it would be an excellent contrasting veneer to the two already being used on the game board. Thicker or more brittle veneers are often shipped flat, but whenever practical, veneers will be rolled to save you on shipping costs. And if that's the case, you're going to want to unroll the veneers and flatten them out to make working with them easier. Simply lay them out and lightly clamp them between a couple of flat panels. Leave them like that for a few days, and they'll be more than flat enough to work with. All of the parts that make up the game board can now be cut from the various veneers. And a veneer saw really is the proper tool for this job. It cuts clean edges on your veneered parts both with and across the grain, and won't try to follow the grain lines like a knife blade will. Start by cutting a couple of sections of each of your veneers at 5.5 inches long. A simple steel ruler makes an excellent straight edge to guide this initial cut. The game board requires at least 52 triangles cut from 3 different veneers, so a template will be used to ensure they're all the same. This is carefully marked out on a small piece of stable plywood or MDF. Then roughed out and carefully sanded to the layout lines. Taking the time to get this template right will pay off as the game board is assembled. The base of the triangular template is carefully aligned with the cross-cut end of the veneer section, then clamped in place and is used to guide the saw to remove the outside waste edge. And being careful that nothing moves, the other leg of the triangle is sawn along the template. The edge of the remaining veneer is already cut to the proper angle, so it can be flipped over, the template realigned, and the remaining leg sawn, and then the process repeated across the width of the veneer section. The design calls for a border between the triangles and the main background sections. These are just long, thin pieces of veneer, also known as stringing. The stringing is cut from a dyed black piece of veneer, using a simple jig to ensure all the pieces are the same width. The jig is made from a piece of hardboard with a rabbet cut in one edge, that is then glued onto another piece of hardboard. The edge of the veneer is fitted into the rabbet, and the lip above the rabbet guides the saw for perfect cuts every time. You also have the option of buying the stringing or an inlay banding already made to use as your border. The last pieces of veneer we need to cut are the center sections of the background. 2 of these pieces are needed, and to ensure they're the same size, a small piece of plywood is cut, and that is used to guide the saw when cutting the background veneers. Four sections are needed to make up the actual gameplay part of the board. These quadrants are made up of the triangular veneer pieces cut earlier. The triangles are pinned to a piece of foam core or common cardboard to hold them in place as they're laid out. A simple strip of tape along the foam core acts as a straight edge to align all the triangles. Begin by placing one of the player color veneers along this baseline, alternating between the colors and filling in with the background triangles in between. Each quadrant begins and ends with a background piece. Use full triangles for now, they'll be cut in half later. The pins keep all the pieces in place while you're working, but don't worry about the holes they leave, those will close naturally as we apply glue and finish. As each quadrant is assembled, it's taped together before the pins are removed. I secured 2 of the quadrants with traditional veneer tape and the other 2 using blue painter's tape. Both work perfectly well, but the blue painter's tape is easier to get, use, and much easier to remove once the quadrants were bonded to the substrate. The outer border pieces of the quadrants now need to be trimmed in half, and another simple plywood template makes this easy and keeps them the same. It should be the same 5.5 inches that the triangles are in height, and it should be 9 inches long according to the plan, but you may have to adjust this a little bit for your triangles. The panels were glued up of cherry, resawn and planed down to 1/4 inch. And this is also a good time to mill up the 1/2 inch stock that will make up the box sides. 2 panels are glued up, sanded smooth, and trimmed square, leaving a little bit of extra in both dimensions. If you don't have the ability to resaw and glue up thin panels, these can be cut from 1/4 inch plywood or MDF, but you will need to purchase extra veneer to cover the outside face. Now begins the veneering process. A line is struck 1/4 inch in along 2 adjacent edges of each panel, and these borders are then covered with blue painter's tape. These marks will be the starting point for laying out the veneer. Traditionally, this sort of veneering is done with liquid hide glue, but it requires specialized equipment, tools, and training. Contact cement is also commonly used in veneering, but absolutely does not allow for adjusting the fit of parts as they're laid out. So that's not the best option for this project either. So we're going to use common yellow wood glue, but not in the way you might expect. Apply an even but complete layer of glue to the face of the substrate and the back face of all the veneer pieces. Then set them aside and let them dry without putting them together. The veneer parts will want to curl from the glue, so pin them down to your board while they dry. As you can see here, my glue coverage wasn't quite adequate. You want smooth but complete coverage across all your parts. A quadrant is now laid glue face down on top of the panel, carefully aligned with the border marks scribed earlier, and secured in place with a couple of pieces of painter's tape. The secret to this entire process is a hot iron. A piece of brown craft paper is set over the veneer, and the veneer is pressed in place using a common household iron set to the cotton setting. The heat and pressure from the iron will bond the 2 dried glue layers between the substrate and the veneer. This is about as easy and effective a process for veneering as there is. One of the black border strings is carefully positioned along the top edge of the quadrant, secured in place, and bonded to the substrate using the iron. The section of background veneer in the center is next, and the same process is used. Note that I'm working from one side to the other. This helps to prevent air from being trapped between the veneer and the substrate. The second borderline is placed and pressed down, and then the second quadrant to complete this side of the game box. A straight edge is clamped along the outsides of the game board, and all of the various components slightly trimmed to give a clean edge. The excess is removed with a sharp chisel. Note how well bonded these parts are, even at the edges. The panels were originally made oversized, and 2 edges scribed with a 1/4-inch border. With the game board laid down, the other 2 edges can be trimmed off so they also have a 1/4-inch border. We won't go too deep into the process of making a box, but there are a few tricks I want to show you as we go. 4 pieces are ripped to 4 1/8 of an inch wide, and each gets 2 grooves, 1/4 inch wide, 1/4 inch deep, and a 1/4 inch in from the edge. Normally, when building a box, the sides would be cut to length, and then the panel trimmed to fit inside the grooves that I created. But I can't do that here because of our veneered surface. So there is a fairly simple trick to get around it. And what I'm going to do is I'm going to dry fit 2 of the sides onto the panels and just lay them up using my parallel clamps. Just a little bit of pressure, just enough to hold everything firmly together. Then I can lay my longer side, in this case, across. I'm aligning it with the panel so that I know it's square, but I'm just going to mark the intersection on the outside of each piece. And I'll do the same for the shorter pieces, rotating this all 90 degrees, and then strike those lines right across. That gives me the final size of my mitered sides. In a perfect world, you could now just lay the bevel of your saw over at 45 degrees, cut all 4 sides, and have a perfectly square mitered box when you're finished. But that's rarely the case. So I'm going to show you a quick tip here on how to get perfectly mitered sides, even if your saw isn't quite up to snuff. Both long sides and both shorter sides are cut to the exact length measured out previously. And using the stop on the miter gauge ensures that both pairs are exactly the same. The ends are recut with the blade set to 45 degrees. But I'm not mitering the full thickness of the material. I'm leaving a small flat at the bottom of each end. The actual miter joints themselves are cut on the router table. Removing most of the waste on the table saw makes for cleaner cuts, and using the router bit ensures that the cuts are exactly 45 degrees. The microjig grip block safely holds and controls the part, and the MDF backs up the cut and keeps the part square to the fence. It's time to start finishing the panels that we've created before assembling the box. But sanding's really not an option here. The sanding dust, especially from the darker pieces, will tend to get into the pores of the lighter pieces, spoiling the contrast that we've worked so hard to create in this panel. And that's where our card scraper comes in handy. The card scraper is a flat piece of quality steel. We've squared the edge and then rolled the corner, flaring a little bit, just a little bit of the steel outward, creating what's called a hook. And this acts almost like a plane blade to microscrape the material, removing material, not creating dust, but rather tiny little shavings that then do not get further buried back into the pores of the wood. It gives us a very fine surface, it's a very smooth surface, and it's a really wonderful technique to add to your repertoire, and I can't recommend it highly enough. You'll want to scrape along the grain of your surface, and using your thumbs behind the scraper to give it a little bend will keep the corners from digging in. The game board should be as smooth and durable as possible, so a clear, water-based grain filler from Crystal-Lac is applied. A soft plastic squeegee is used to work the grain filler into the pores, working diagonally across the grain, sort of like grouting tile. Several layers of a high solids top coat is what's recommended, and with boxes it's almost always easier to finish all the parts before assembly. Just avoid getting finish on the miters. Assembling the game box is quick and easy. The side pieces are laid out in order, face down, carefully aligned with one another, then secured together using painter's tape. This assembly is then carefully flipped over, and glue is applied to all of the mitered faces. Cover the edges completely, but sparingly, to avoid squeeze out. The panels are then inserted into the grooves, and the box sides wrapped around them. The tape applied previously acts as a hinge, holding the joints together and aligned until clamps can be applied. Get all the clamps properly positioned before applying any pressure, and gently tighten the clamps in sequence, applying pressure equally in both directions to keep all the mitered faces aligned as pressure is applied. Now the sealed box can be split in half on the table saw. This is why the sides were created to 4 1/8 wide. The rip fence is set to 2 inches, the blade set to just over a 1/2 inch high, and 3 of the 4 sides cut with the saw. Cutting the 4th side like this is not safe. The box could come apart uncontrolled or could pinch the blade. A pair of spacers, the same thickness as the blade, are slipped into the kerf of the box, and gentle pressure applied with a clamp to hold everything together during the cut. A few quick passes with a good quality block plane will clean up the sawn edges. Building the box as one unit and cutting it in half ensures that the grain pattern will match when the box is closed. The final details to complete the game board include a pair of hinges, a couple of latches, and a handle. As I mentioned at the beginning of the episode, if you don't have a lathe, you can simply buy the game pieces to go with your backgammon board. But for those who do have a lathe, here's how I turn the pieces for my game. The counters, or checkers, can be any size or style that you like. The important part here is that they're all the same. So I turned one that I liked and double-face taped it to my tool rest, which made turning consistent pieces much easier. As each checker is turned and sanded, it's much easier to finish them while they're still on the lathe. I used Doctor's Woodshop Walnut Finishing Oil, simply applying it with a paper towel while the parts were still turning. The checker can then be parted off and the whole process repeated 15 times for each color. The backgammon set should also include a dice cup, and should you decide to turn one, it's not all that difficult. I turned mine with a slightly narrowed waist and a bead detail on top and bottom. The waist at the top of the cup was parted off and a 1 3/8 hole bored into the center. If you have a drill chuck for your tailstock, boring out the waist really speeds the hollowing process. The cup is sized inside and out, large enough to allow the dice I bought to be properly shaken, but the sides shouldn't be too thin. The finish here was also walnut oil applied on the lathe. And finally, the cup parted off. And that's all there is to it. The backgammon set is now ready for game night. In the next episode of Woodcademy, I'm going to show you how to use the factory miter gauge that comes with your table saw. We're going to accurize it so it fits properly within your slot, show you how to clean it and tune it up, and show you an easy way to set angles perfectly every time. And as a bonus, we'll also show you how to make this excellent auxiliary fence. It can slide back and forth to adjust to the blade position, whether you're angled or not. Has a flip stop that can be positioned anywhere along its length, and an extension for longer pieces. So be sure to join us for the next episode of Woodcademy TV. Woodcademy is made possible with the generous support of our sponsors. Please take a minute and let them know how much you appreciate it.